Hey guys, before you get started today, I want to have a quick recap of what we looked at last class on quadratic functions. First of all, we started with the standard form of a quadratic function, which was y equals ax squared plus bx plus c. Here, we'll look specifically at the quadratic function y equals ax squared plus 8x minus 20 and try to use our skills from Unit 8 to write two equivalent forms in factored form and vertex form. To achieve factored form, we must factor that quadratic trinomial. So we will say our leading coefficient, which is an invisible 1, times our constant, which is a negative 20, would give us negative 20. When factoring, we would end up with 1 times 20, 2 times 10, and 4 times 5. We also know that one of each pair needs to be negative so that they would multiply to give us a negative number. Now, I've made the smaller number negative so that when they combine, we would end up with a positive b value. We notice that 10 plus negative 2 would give us a positive 8. So I've rewritten our expression as x squared minus 2x plus 10x minus 20 because negative 2x plus 10x simplifies to 8x. From there, we're going to proceed by factoring by grouping. Let's make two groups. Then we'd factor the GCF out of each group. Now we can take the x minus 2 and factor it out of each group, which leaves us with x plus 10. Hence, we have our factored form of the quadratic equation, y equals x minus 2 times x plus 10. Now, we will use those factors to solve for the x-intercepts. Anytime you have an x-intercept, you know that the y equals 0. So here we have substituted 0 in for y. Now we will set each factor equal to 0 in order to solve for x. First, we have 0 equals x minus 2. If we use the inverse operation and add 2 to both sides, we now have x equals 2. We'll repeat this process with the factor x plus 10. Subtract 10 from both sides, and we have x equals negative 10. Hence, 2 comma 0 and negative 10 comma 0 are the x-intercepts of this quadratic function. To find our vertex form, we must use our skill for completing the square. We know that we need to substitute 0 in for y so that we can manipulate the equation. We'll add 20 to both sides because 20 is not the c value we're looking for. Once we do that, we have 20 equals x squared plus 8x. I want to add 16 to both sides, which gives us 36 equals x squared plus 8x plus 16. Now, x squared plus 8x plus 16 can be factored into x plus 4 squared. So I'm going to rewrite that in this step right here. After I've rewritten it, I can move my 36 back to the right side by subtracting 36 from both sides, which gives me 0 equals the quantity x plus 4 squared minus 36. Now I've simply replaced my 0 back with the y. Hence, we know the vertex is going to be negative 4 comma negative 36 as h comma k represents the vertex. Here, h is negative 4 and k is negative 36. Remember, you can't notice because I don't have it typed out here, but remember that the x value in the vertex form of the equation has a sign opposite. I'll add in that vertex form of the equation for you. Y equals x minus h parentheses squared plus k. When you have this vertex form of the equation, the negative sign already exists inside the equation right here. So when you're identifying your h value, it's going to be the opposite of whatever it appears to be. Since this is a positive 4, we must have said x minus negative 4. It's really easy just to remember that the x value is opposite. Once you've graphed an equation, so if instead of breaking that down algebraically, I took my equation and graphed it, we can identify those key features on the graph. We know that when we look at the x-axis, these 2 points would be our x-intercepts, which we just found to be 2, 0 and -10, 0. Excuse my bad handwriting. I'm trying to write this on a trackpad. Then we can clearly see here in this graph that our y-intercept is -20. So we would write that as 0, -20. Finally, our vertex can be found as the turning point of the graph. And we just talked about that. Our vertex would be -4, -36. We also discussed that the vertex would be classified as one of two things, a maximum or minimum. Here, our vertex is clearly a minimum value as it is the lowest point of the graph.